So the topic that we are looking here is molecular biology topic, and what we will be looking at is the properties of replication. Within that, a very specific aspect of replication, what we call it as semi-conservative replication. So the semi-conservative replication, the idea was given by Watson. When they gave the double helix model, in the double helix model, they proposed because the two strands of DNA are complementary, there is a possibility of semi-conservative replication. So the entire concept of semi-conservative mechanism came from one of the properties that was described by Watson and Crick model, and that particular property is the complementary state of the two strands of DNA, where the nucleotides in one strand determine the nucleotides in the other strand. So these nucleotides in the strands are non-identical but complementary. So that became one of the important features of replication, because when you have semi-conservative replication, you already have a template that can provide you the information for incorporating the nucleotides. That means your new nucleotides are not randomly incorporated. They are incorporated according to what nucleotide is present in the parental strand. So when the replication is completed, we get a daughter molecule having a hybrid state in the parental DNA strand and a newly synthesized strand. So we are having a hybrid daughter DNA molecule having one parental DNA strand and one newly synthesized strand. So your parental DNA strand and newly DNA strand combine to generate a new form daughter DNA. Remember, this mechanism is not similar to that of photocopying. Although we will generally consider this as a class of photocopying process, this is not a photocopying, or this is not the trade name Xerox. The reason is, here we have a mixture of new and old strands. In photocopying, you get your original, you get a new one as a copy. This kind of mechanism, if it occurs in replication, we call it as conservative. So we go for the photocopying for simple reason. Our original is not modified, the original will be written along with the copy. So your original will be always safe. Here, your original is not safe because of the original molecule, half the strand will be transferred to the next generation daughter cell, and the remaining half will be transferred to another daughter cell. So that's why it is semi-conservative mechanism, but it is not photocopying. So what happens if you have a semi-conservative mechanism, and why it is so important? In the case of a semi-conservative mechanism, If these are the parental strands in one generation, or you can call it as parental generation. So this is parental generation. These are the parental strands. When the semi-conservative mechanism is upright, semi-conservative mechanism, the parental strands will get separated and they act as the stimulates. It's not complete separation, but as the synthesis goes on, they get separated and they start making a new daughter DNA molecule having one parental strand and one newly synthesized strand. So you can see the hybrids. So there are hybrid DNA molecules having a parental and a newly synthesized strands. So that means you have your original always with the newly synthesized. So now what advantage you have? Winner replication cannot occur without errors. When you have a semi-conservative mechanism, whenever the errors takes place in the newly synthesized one, that is the white one, whenever errors occurs in the white one, the DNA repair mechanism can identify the error based on the parental strand. So the parental strand always tells what should be in the newly synthesized strand. When it is different from the required one, then a repair mechanism corrects so that at the end of the replication, you are not going to see any significant error. So it doesn't matter what happens to the replication, there may be error taking place, but once the replication process is completed, once the second strand also gets methylation, then you have no significant frequency of error in the DNA replication mechanism. This ensures that your genetic material passes from one generation to another generation successfully without getting any damage. So progress to successive generation without any significant damage. Don't say that there will be any damage, but most of them may not be significant. So that was the reason people have only concentrated on semi-conservative mechanism, whether it is in vivo replication or in vitro synthesis. The replication follows semi-conservative mechanism. The experimental evidence for this mechanism was given by Messerson and Strong. So they gave the experimental evidence in the 60s. Here the time when Watson and Crick got their Nobel Prize at the time. They worked on the organism E. coli. At the time used to be called as the workhorse of molecular biology. Even today this is the workhorse of molecular biology. So he was working with E. coli. He was using two different isotopes of nitrogen. He used them in the form of ammonium chloride salts One is a heavy nitrogen salt. Second one is a lighter nitrogen salt. So this is heavy nitrogen. This is lighter nitrogen. This is non-radioactive. Be careful there because often people confuse it as radioactive. 15 nitrogen is non-radioactive, so this is stable isotope. This is also non-radioactive. This is also stable isotope. So this experiment uses only non-radioactive stable isotopes. This experiment will not use any radioactive isotopes. So that's why we don't go for any autoradiography for finding out the results. We go for centrifugation technique. And this centrifugation technique is called isotechnique density gradient centrifugation. And the method isocentric density gradient centrifugation separates the molecules based on their densities. So separation is based on a phenomenon which is called as Bayan density. So Bayan density is not new term, it is a density of a particle where the particle floats in a medium having the same density. So if you have a medium, density gradient medium. So you have low density at the top, highest density at the bottom, and as the particle moves, so these are the particles that we have on the surface during the centrifugation. Then we made centrifugation. So now what happens is particles separate as per their density, and they will form bands. So you can see here the particles which were allowed under the separation in the gradient separated into three distinct bands. We don't call precipitates, we don't call pellets, we call bands. So it's more similar to that of thermophorus rather than the usual centrifugation. It forms only the bands but not the pellets because the density of the medium at the bottom will be always higher than the density of the densest particle. So if I have a particle of 1.9 grams per mm, I go for a density of 2.1 so that my particle will float at a particular position rather than sinks into the bottom of the centrifugation. This is critical for this kind of centrifugation. We don't want to pellet, but we want to separate them as the bands. So what they have done is, they used initially the equalizers in N15 medium for several days. So take the equalizers, keep it in a medium where there is only heavy nitrogen as the nitrogen supplier. So every nucleotide that is synthesized in this bacteria will get N15 or heavy nitrogen. So you can take about 1 week. So in 1 week you get plenty of generations, and the last generation, whatever you are considering for the experiment, we have only nitrogen with N15. That means all the bacterial cells here will have only heavy DNA. That we can write it as N15/N15, indicating both the strands of the DNA are made up of heavy nitrogen. After this, you transfer to light nitrogen medium to see what happens in terms of the nitrogen accumulation. So transfer to lighter nitrogen medium. After the transferring, you wait until 40 minutes. So one generation is completed. You take the DNA and then you centrifuge the DNA. Then after 80 minutes, you take the second sample. You take second set of equal cells. From the cells you extract and obtain the DNA and again make it to go for isopropyl density gradient centrifugation. Similarly, after 2 hours, you do the third generation centrifugation. Okay, so we are having roughly 40 minutes generation value. This you can change as per your requirement. So most people like to have that 40 minutes, so it's comfortable for equal life. 30 minutes you can undergo the replication, 10 minutes is undergoes the division. So the generation time is 40 minutes. So first, after completion of the first 40 minutes, you take a small amount of equal cells, extract the DNA, centrifuge it. Then after 80 minutes, you take another set of equal cells, then you do the extraction. And then after 2 hours, you take one more set of equal cells, you extract the DNA, and then you find out based on the biodensity where the DNA comes. So when they have done this, at the end of first generation, they found a single band corresponding to hybrid DNA. There was only one band, and that band was hybrid DNA. Hybrid DNA means it has one strand which is made up of N15, one strand which is made up of N14. So the N15 came from its parent one. N14 came from the newly synthesized. So 100% hybrid DNA. This rules out conservative replication because in that case we should get heavy DNA and hybrid DNA. But it may say replication may be semi-conservative or dispersed. When we have continued experiments, so second generation, what I found is, in addition to the hybrid DNA band, they also got a lighter DNA band. So now we are getting 2 different bands. We are not getting anything called heavy, but we are getting a hybrid DNA band and the lighter DNA band. And when they had gone for the third generation, again they got a lighter DNA band and a hybrid band. So now the hybrid band is relatively less, the lighter band is relatively more. So gradually the lighter DNA is increasing. The hybrid DNA proportion is increasing. So typically 50%, 50%, 50%. Now, how we can conclude what kind of replication from second generation? So first generation we said replication cannot be conservative, but it can be semi-conservative or it can be dispersive because it is giving hybrid DNA. Second generation, we are not only getting the hybrid DNA, we are also getting a lighter DNA. Because we are not getting only hybrid DNA, this rules out the possibility of a dispersive mechanism. So it can't have conservative mechanism, you can't have dispersive mechanism. It proves that the replication is semi-conservative mechanism. In the third generation, your lighter DNA is further increasing because now every replication goes on increasing the lighter DNA strands. So, further proves semi-conservative mechanism. So that's how, through a very simple experiment, using two different isomers of nitrogen, one heavy, one light, they could identify and prove that the experiment that the replication of the DNA occurs by a semi-conservative mechanism in which one of the two parental strands will act as the daughter strand and the other will be synthesized based on the parental strand. If you want to find out the proportions, the proportion of heavy DNA after transfer to N14, it will be 0 because nowhere in our experiments we get heavy DNA. So heavy DNA only comes under the synthesis, but once you have transferred in the Meselson star experiment, there are no heavy DNA molecules. The proportion of hybrid DNA molecules after the transfer will be 1 over 2 raised to power n minus 1. So first generation means it will become n power 2 power 0, that is 1 divided by 1, which is 100%. If it is second generation, it will become 1 divided by 2 power 1, that is 50%. So you get 50% hybrid DNA, 50% lighter DNA. If you go to third generation, you get 75% of lighter DNA, 25% of hybrid DNA. So that's how the proportion of the hybrid DNA is gradually decreasing from 100% to 50% to 25% to 1.5% to 6.25% and goes on. What about the lighter DNA? Proportion of lighter DNA molecules. So we know this is the hybrid DNA, and the total DNA is 1. So if you subtract, you get it. So here the lighter DNA is 0. Here 50 minus 100 minus 50, that means 50%. Here the hybrid DNA is 25% and the lighter DNA is 75%. So 100 minus 250. So whether you are looking in terms of the hybrid DNA, it starts with 100%, decreases to 50%, decreases to 25%, decreases to 1.5%. So it is undergoing exponential decrease. Similarly, when you take the lighter DNA, it's 0% given, then it has become 50%, then it has become 75%, then it has become 87.5%. There is exponential increase. So the exponential decrease and the exponential increase are indications of the semi-conservative mode of replication. If you had either the conservative, then you should have got always these bands, or dispersive, you should have got only one single band of 50 generations. You can exclude those two mechanisms and conclude that the replication takes place by semi-conservative mechanism. So this is the only one that is so far identified. So far, only semi-conservative mechanism is identified. So, with these experiments, we say replication is semi-conservative, but we can't give any further saying that the other mechanisms are opposite. We have not yet identified the other mechanisms, but there is a possibility somewhere, sometime we may get the other kind of mechanisms also. Or we may not get those other kinds of